Hello, Assalamu alaikum. Good morning, everyone. Welcome to the class. Yes, thank you. Walaikum assalam wa rahmatullah. Yeah, walaikum assalam wa rahmatullah. Yeah, so this is the introductory class, first class actually. Yeah, so formal first class you can say. So we will start about some basic information about the computer system or digital computer system. So let us have a look. Most of the things are very basic idea for information. It's not like you have to memorize things like that. So you know, right now we are using, I said you in the first class that we are using laptop, desktop. The processors are in from Intel, mostly Intel actually, because Intel processor, I mean same configuration but different processor. Intel processor based computer is expensive compared to like other types, Celeron, or there is a few other companies actually. So Intel, so mostly we like the Intel processors, Intel processor based computer system. So let us just have a look for information, not for memorize, not for to memorize. So evolution of digital computer. UNIVAC was the first commercially mainframe computer used by the US government in 1951. So it uses 5200 vacuum tubes that requires 125 kilowatt of power to perform 1900 operations per second. So this is like that, UNIVAC. So UNIVAC is Universal Automatic Computer. So look at here, it's a big picture. I mean, it's a big machine. Now, a laptop, look at the laptop. It's a very small in size, but very powerful. So things are becoming more powerful and more compact. I mean, more small in size. So this is the I mean advantage. I mean technology actually makes the things this way easy for us. And IBM 650. It is the international business machine. 650 was the first mass-produced computer, as 2,000 of these computers were manufactured and supplied from 150 to 162. So this one was the business machine. I mean, first mass-produced computer. Okay, and then you can see that it's a big in size. A power supply in one side, a magnetic drum, memory console. This is in one another box like that, and yeah, and computing system is in another. I mean, microprocessor and things. Motherboard. You can say the motherboard. All the things in another side. It's a big in size and occupying big in room, big space in a room. Then in 1954, silicon-based transistor, junction transistor. So transistor actually, the advent of transistor actually made the major change in the computer system. So the second generation computer system introduced in 1954 due to the advent of silicon-based transistor, where vacuum tubes are replaced with junction transistors, and yeah, as a logic gate. Yeah, junction transistor, it can be used as a logic gate. It can be used in many other purposes. So all kind of many kind of operations it can be performed by the transistor. So logic gate also is one of the application. So in 1955, the first fully transistorized digital computer, TRADIC, it was manufactured using almost 700 to 800 transistors and 1,000 diodes. So silicon-based devices like diodes, transistor, they actually help to make the revolutionary change. And IBM 7000 series was the first transistorized computer made by the IBM with 1 million instruction per second capability. So if in 1 second it can perform 1 million instruction, 1 million programming line, you can say. So that means, yeah, in 1958, the invent of integrated ICs and semiconductor IC. So integrated IC, all of you finish the electronics. So like integrated circuit, many things can be integrated together in a small area. So this is integrated. If for example, if you finish all of you finish the 200 E200. In 200, you can see one IC, in a small one IC, integrated IC. IC means integrated circuit. Okay, in one IC, it has many for example, and so NOT gate IC. In small NOT gate IC, we have like around, I think, eight NOT gate are there, and each NOT gate is built on based on transistor, like that. So you can think about it. This is a simple example that one integrated IC, it can have many transistors inside there, something like that. So so invention of the integrated IC technology actually makes the things more change, lead to new generation of commercial computers called mini computers. So, and yeah, these are the things like that. And in 1971, the release of first commercial microprocessor, Intel 4004. Okay, now we are using like Intel Core i7. So in 1971, back to 1971, first commercial microprocessor was Intel 4004. So revolutionized the computer industry and resulted in new generation of microcomputer, also known as personal computer PC. Later in 1973, a French company developed Micrel, a low precision personal computer. Due to its high cost, like $1,750, this computer was never marketed. Anyway, so microprocessor. So now we say that in 1971, the first commercial microprocessor was Intel 40. So what is microprocessor? It is also called the CPU, Central Processing Unit, or the brain of the computer, personal computer or computer system, microcomputer, you can say. So a laptop is an example of microcomputer. So the desktop is a microcomputer, but inside this microcomputer, there is a there is a board. It's called motherboard, and on that board it has a processor or brain that is called microprocessor. So it is called also CPU, Central Processing Unit. Okay, so it is an integrated circuit. So microprocessor is an integrated circuit built in on a tiny piece of silicon. You can see the size is very small and contains thousands or even millions of transistors which are interconnected via superfine traces of aluminum. These transistors work together to store, manipulate data so that processor can perform a wide variety of useful functions as dictated by the software. So definitely software, actually based on the software it works. So software and hardware. So microprocessor and supporting devices are hardware, and so like a computer or laptop, desktop. So it is a hardware system, but to work something we need a software, right? Based on the software it works. What kind of what kind of operation it perform? What software actually you want to run, something like that. So in 1977, first desktop computer TRS-80 was released with most of the required accessories and inbuilt programming language BASIC. So BASIC was the one of the I mean, one of the first few primary programming language, BASIC, basic. And in 1981, IBM's first PC was marketed, and it ran an Intel's 4.77 megahertz 8088 microprocessor. Okay, so this is the one of the Unibic didn't have microprocessor. I don't think so, because it was microprocessor was developed very late. I mean, not that earlier time. Yeah, so Intel's 4.77 Intel's microprocessor 8088. 8088 it was used in IBM's first PC. 8088, and its clock frequency is 4 because all the digital IC, they were synchronized with the in clock pulse, pulse. So pulse is frequency is 4.77 megahertz, and came with MS-DOS operating system. Now we are using Windows operating system. So Windows, it came later, but previously MS-DOS, Microsoft DOS operating system it used. So the main component of PCs are briefly introduced in the next slide. So main thing is, so that means what we have learned, that first marketed PC uses the 8088 microprocessor. And in this course, actually, we learn 8088 or 8086. So they are almost similar, only slight difference. But sometimes you see 8088, sometimes you see 8086. So it doesn't matter. So what was the best technical specification of Intel 4004? That was the first commercially microprocessor. Its clock speed was 740 kilohertz. Now look at here, we are using the computer with the microprocessor. Its clock frequency is gigahertz. Now it's not kilohertz, megahertz, it's gigahertz. Very fast. So if clock frequency is gigahertz, that means it performs the things very fast, and executed almost 60,000 instruction per second. It was about 4004, Intel 4004. You can see Intel 4004. So Intel 4004 was the first commercially released microprocessor. And it has some register. So what is register? Register is some memory space devices inside the microprocessor. It's not like normal memory like RAM, ROM, right? External. They are called external memory. And some the microprocessor has some memory space. They are called registers. Registers, it contains 16 registers of 4. It has 16 registers of 4 bits each. Each one is 4 bit. Like 1, 0, 0, 1. So that means it is a 4 bit. Okay, 4 bit data. So 16 register of 4 bit. It is about the Intel 4004. And separate operations and data storage with single multiplex 4-bit bus for transferring 12-bit addresses, 8-bit instructions, and 4-bit data words. Instructions set contains 46 instructions. A Japanese company used them to build calculators. Okay, to build calculators. This is about some basic information. Okay, now it's about the something more about the in a microcomputer architecture. What are the things like a laptop is a microcomputer? So what are the main components we can say inside it? So one of the this one is the called memory unit, and this one is called the CPU. You can see CPU is the microprocessor. It has some internal register like AX, BX, CX. We'll learn it later. Okay, CPU, and it has some input units like keyboard, mouse, These are the things. Definitely it has some output in it, like display like monitor, you know. So we are without looking actually what is going on, how can we understand? Huh? How can we know it? So we need some display. Also printer is kind of output unit. And the CPU works with a clock pulse, because you know digital device, they to synchronize all the operation, it must work in synchronized with the clock pulse, definitely. So now the clock frequency is gigahertz, you know. So this is like a clock pulse. This is like a clock pulse. Okay, pulse. So the frequency of this clock pulse, if it is higher, that means the operation of the microprocessor is going on very fast. All right, so that means, okay, what about the memory unit? You can see the memory unit. Inside the memory unit, what are the memory unit? We can divide it in two categories mainly: primary storage memory and secondary storage memory. In primary storage memory, also it can divide it into two groups, and program storage memory and data storage memory. Okay, and there is something secondary storage memory. So program actually, like you know, the code, the instruction, that the programming language, we can use different languages like C, C++. You already finished the codes. We can write in Fortran, we can write in Basic, we can write in Java, we can write in MATLAB, whatever it is. So this is saved in the program storage memory. And we have sometimes we have some data, you know, to process, that actually we have to process. So data is data storage memory, and something is secondary storage memory. Okay, so CPU or MPU, CPU central processing unit or microprocessor unit. CPU microprocessor unit is implemented with a VLSI device, very large scale integration device, as a because inside it has a many ICs. In this IC inside it has a many a lot of transistors, diodes, and many other things. Yeah. So that's it is now also known as a microprocessor, or just processor for short. Shortly we can say processor or microprocessor. It is responsible for performing all the arithmetic operation and making all the logical decision initiated by the computer's program. You know, like in our program we have to do many arithmetic operation: addition, subtraction, multiplication, division. So these are the arithmetic. Sometimes we have some logical operation, like if it is if if it is, do it, otherwise do other things. So these are the logical decision, right? So all the things are performed by this CPU microprocessor. In addition to arithmetic and logic function, microprocessor also controls the overall system operation. You know, definitely it also coordinate all the things. And input output units, we already know it. Input units is like a keyboard on IBM PC. Allow the users to input information or commands to the microprocessor unit. And many other input devices are available for PC. Two examples include a mouse, and for implementing user-friendlier input interface, and a scanner also for reading in documents. The most widely used output devices of a PC are monitor, you know, monitor is and also the printer. So output unit is used to give the user feedback and to produce documented results, you know. So the result we can see. And memory subsystem, we say that memory unit, it is primary memory and secondary memory. So primary memory is normally smaller in size and temporarily stores active information, you know, such as the operating system, like Windows, programs that are currently being run, data that are currently being processed by the computer. These are the things in primary memory. And what is the secondary memory? It is large, normally large and used for long-term storage of information that is not currently being used by the PC. Typically, this memory represents the external storage media and hard disks. such as like hard disks or floppy disks. Previously, if floppy disks, we during our student life we use the floppy disks, not the portable hard drive. It was not available that time. Floppy disks, we use small size. Yeah. So these are the things. 1.44 megabytes size, and also CD, compact discs like CD read write, and different types of DVD. Yeah, we can see the DVD, digital video discs. These are the things are available in them, and also we use it. So these are the secondary memory. Okay, typically primary storage is implemented using CPU registers. Okay, primary memory actually basically mostly it is part of the microprocessor, because it has some registers, some memory storage are there inside the microprocessor. They are used. I mean, what are the currently currently used programming language, programming lines, data that are currently in use. They are saved. I mean, they remain in the primary memory. Typically, primary storage is implemented with CPU register, caches, RAM also kind of, RAM also example of primary storage memory, ROM, etc. Okay. And CPU registers, as I said that microprocessor or CPU, it has some registers. So like other memory, like external memory, for example. So RAM, ROM. If you want to access this data, you need it is little bit slower compared to the register inside the CPU. So because CPU is already inside the microprocessor, it can be accessed. I mean, these registers are accessed very quickly. So fastest storage elements where frequently used temporary data is stored and accessed by the specifying the register name. Like for example, AX, BX, CX, they are the different types of registers name. So just using the registers name, we can access the data. We can access this register or this memory elements. So, but like for the external memory, we need address, we need. I mean, it's a little bit slower process. So memory, and their RAM, random access memory, usually called the main memory of PC, where address memory locations are used to temporarily store or write information, which can be accessed, read at any time at equal time periods, hence the name random access. So I mean, random access memory, RAM, is typically implemented using ICs often called memory sticks, such as DLP60 pin, SIPP, SIMM 30 pin, different types of examples, RAM. And there is another types of memory is called ROM. ROM, it a read-only memory. So it is called read-only. We can read only, we cannot write. Normal process we cannot write. But yes, there are some other technologies there that actually helps to write something on the ROM. But we cannot erase it. We cannot. We cannot delete it normal way. So it stores information permanently, and also can randomly access the stored information. ROM is usually used to store the information required by the computer to start up or initiate the booting sequence. The booting sequence, when actually we press the start, power button. Actually, it takes some time, to boot up or to start up. So the software all the required softwares are saved in the ROM actually. So these are the things. ROM is usually used to store the information required by the computer to start up or initiate the booting sequence. And recent type of ROMs that are used in microcomputer are called flash or CMOS, different technology. Okay, and there is another term is called cache. It is also a kind of memory elements. It is very fast of type of RAM that is used to store information that is most frequently or recently used by the computer. Recent computers have two levels of cache. The first level is faster but smaller in size. It is called internal cache, and the second level is slower but larger in size. Okay, so what is the summary of this page? We can see that what are the memory elements related to the microcomputer system. One is the thing is called CPU registers. They are inside the microprocessor. They are fastest storage element because they are very closer to the microprocessor inside, and they can be without address. It doesn't need any address, but other memory elements like RAM, ROM based memory elements, they need address. If you want to get any data, if you want to write any data, you need address, otherwise you cannot. Okay, so this is one of the thing, CPU register. And there is another thing, it's called RAM. We have some basic idea about RAM. What is RAM? It's random access memory. We can read it, we can write it, something like that. Read-only memory is just we can read it only. We cannot write it. We cannot write it or erase the information. And there is another thing, is called cache. So cache actually is it is RAM based, but it is used for temporary storage of information like instruct that are currently used by the microprocessor. This is called cache. Okay, and there is another terminology, you may say bus system. So bus is actually just like a wire, wire. So it can be either, because in a digital computer system, it is either logic 0 or 1. 0 or 1. So logic 0 means like a 0 volt, or logic 1 means like a 5 volt or 10 volt, something like it depends on the system. So either logic 0 or 1 or 0 volt or 5 volt, something like that. So the three types of bus are there. One is called address bus, one is called data bus, and one is called control bus. So address bus actually, it carries the address information of memory or input output system. Memory or input output system, because memory, they must have the RAM ROM based memory, they must have an address. Otherwise actually which location you will go, because memory, it has many memory location, like for example many cells. So for example, like we say 1 kilobyte memory. So 1 kilobyte memory means 1000 byte size. Byte means 8 bit, 1 byte means 8 bit. So 8 bit, 1000 memory location, each cell is 8 bit. It is called 1 kilobyte. So 1 kilobyte memory, that means each location. So that means 1000 memory cell. Which one you want to read? Which one you want to access? Simple thing. Which one you want to access? You need an address. So address bus actually, the wires that are used as an address bus, they actually carry the address information, physical address information. And what about the data bus? They actually carry the data. So it may be 8 bit, it may be 16 bit, depends on the system that carries the data. It actually carries the data information to be read or write. We can write some data into memory devices, or we can or input output system, or we can read data from the keyboard. From the keyboard, data is read by the microprocessor, and to the output system like a display, data is write. Data is write by the microprocessor on the output system. And same like memory, you can read data from the memory, or you can write data on the memory. So data bus. So that means data bus are bidirectional, because it can be read or write. So write operation. So bidirectional. But address bus are unidirectional, because they just carry the address information. It's not about read and write related. And there is some bus, some wires they are used as a control bus. It carries information that controls read and write. For example, read operation, write operation, memory related operation, or input output related operation. These are the things are controlled by the control bus. Okay, so this is so that means 3 types of bus are there. One is called data bus, address bus, and control bus. So now the basic hardware setup of a microcomputer, if we represent the microcomputer as a block representation, microcomputer in a block, we can say this is the microprocessor, right? Like for example, 80x86. It may be 8086, 80186, 286, 386, something like that. Because with the revolution, with the technology, with the help of technology, things are becoming new version, like 8086, 80186, 286, 386, 486, something on, and then Pentium 1, Pentium 2, so on. Okay, anyway, so this is a microprocessor, for example, CPU. So what are the things inside there? I mean, connected. So it actually it doesn't work alone. Okay, so it needs some other hardware peripherals. Other peripherals are there. So like for example, a graphic adapter is connected with the microprocessor. It actually related to the monitor, because graphic adapter must be there. Without graphic adapter, it actually helps to be connected with the monitor. Okay, and it has some external memory devices like ROM and RAM, and also there are some other timer, DMA, interrupt things are there. There should be, and also some input devices like keyboard, mouse, speaker. They're the input units. All right. Okay, and the external hardware devices like external hardware devices like hard disks, floppy disks, they are connected to the microprocessor through a controller. Hard disk, floppy disk controller. Without controller, actually sometimes we cannot directly connect it, because we need sometimes. It can be possible sometimes, but things will be more complicated. That's why sometimes we need a controller. Different types of IC. Controller is also another IC, that actually controls that actually helps to be connected. Okay, and then we have some output devices like printer, modem, LAN. Okay, so these are the LAN hub. It is for Wi-Fi or internet connection. So LAN hub is local area network. It is connected with the adapter and then CPU. And then whatever the modem, it is connected to the serial interface, and printer it is connected with the parallel interface. You can see on the if you look at the laptop, you can see there are some options, on each sides to be, so that we can connect some external things, like we can connect the printer with the laptop or desktop, or sometimes we can connect like some other like other devices, like for example, in the classroom, like we use some VGA card. Through the VGA card we connect it to the projector. So these are the I mean, some it has some parallel interface, it has some serial interface. So one of the example is modem. It is connected with the serial inter. One of the common use of parallel interfacing device is printer. So this is about the basic information. What are the things actually? I mean, how the things are connected in the microcomputer system. Okay, so this is basic information. Okay, now we'll I mean, discuss some more basic some information, like how the evolution of the Intel processor is happening. Like 5 standard data widths are evolved for microprocessor and microcomputers, and like 4-bit, it starts with a 4-bit microprocessor, then 8-bit, then 16-bit, then 32-bit, and now it is 64-bit. You can see some now the most of the microprocessor 64-bit microprocessor. So it means its data size, data bus is 64-bit. If it is 32-bit microprocessor, that means data bus is 32-bit. If it is 16-bit microprocessor, that means data bus is 16-bit, something like that. Okay, so 16-bit, 64-bit microprocessor, 32-bit, yeah. And also you can see some operating system also, Windows operating system, you can see that it is 64-bit. Some Windows operating system like Windows 10, it is 64-bit. Windows yeah, XP, these are the 32-bit, so different types of because they are compatible with 32-bit. Each microprocessor is compatible in, each different types of microprocessor, operating system, or different types of software. Software also, like a different software, it is also compatible with certain types of microprocessor system. So like how can we understand it? How can we know it? That it is 34-bit or 64-bit or 16-bit, something, so on. All right. So now have a look. For example, the first one of the early microprocessor is 8080, and then 8085, then 8086, and 8088, 80286, 386, 486, Pentium 2, 3, 4, and then Celeron. No, sorry, then iCore is there. So it has like in which year it first becomes available, like 1974, 70, so on, and how many transistors it uses. Look at here. I mean, a huge number of transistors are there, and data size is also, with the time it becomes bigger and bigger. So now Pentium 4, it uses 64-bit data size, and speed is also becoming higher and higher. You can see 2 megahertz. It starts with 2 megahertz, and Pentium 4, it's like, it was used in like Pentium 4 is like in 2003, 4 times at that time. It's Pentium 4. Now it's yeah. Do you have any idea what is the clock speed of this iCore? Core i7. Definitely it's in gigahertz, but it's very high actually, not 1.5. It's very high. Okay, anyway, so it's just for information, us giving us some, like, things are how the clock show. Yes, definitely clock speed is, if it is faster, that means processor is able to work faster. Okay, so look at here, this is an IC 8086 IC. You can see at the first line 8086 microprocessor IC. So it is the brain. It is the brain in the motherboard. And as I said, 8086 or 8088 family, it provides a superset of the earlier devices architecture. Definitely, what was before 8086, it has an upgrade version, superset. And the features offered by 80386 microprocessor are a superset of 80286 microprocessor. Definitely, it's more better than 80286 or 8086. And those of 80286 is superset of 8086 or some so on. Okay. And also you can see that with the time, I mean, it is a graphical presentation of different model of microprocessor, and they are and there are millions of instruction, millions of MIPS, millions of instruction executed per second, millions of instruction executed per second. So definitely it's becoming more and faster. Okay, if you look at it. And this is already we said. Now we will see that, you know, sometimes you have during your project, final year project, you use some microcontroller, like Arduino. So Arduino is microcontroller actually. So Arduino is not a microcomputer, or it is microcontroller. So microcontroller means actually it has a dedicated, it is used for dedicated purpose, and inside it has all, I mean, all the things are inside there in a small board. Yeah, Arduino. So Arduino is a kind of microcontroller, you know, because I mean, is one board has lot of the things. You cannot use it for, I mean, you cannot replace your laptop or your microcomputer with this microcontroller, because microcomputer or laptop, desktop, they can be used for varieties of application, but microcontroller is for dedicated application. Okay, it's for dedicated application. Inside the microcontroller, it has also microprocessor, but different types of. That is who you want to discuss. One is called reprogrammable microprocessor. One is called embedded microprocessor. So embedded microprocessor is used in the microcontroller. It is embedded and it is used for a certain types of application, like, you know, for example, your project, you want to use it for your project. So this is embedded, and the program you build in on there, and it works based on the program. Okay, this is called embedded microprocessor. Like example is like a microcontroller. In the microprocessor used in the microcontroller. And reprogrammable means you can reprogram it whenever you want. Different types of program you can install it, like the laptop, desktop, something like that. Okay, so Intel microprocessors into two applications. One is called reprogrammable, one is called embedded. So you can see that reprogrammable microprocessor series is like 8088, 8086, 80286, 80386, 486, Pentium, and now it is Core i7 core. For example, now it is Core i7, for example, now. So these are all reprogrammable microprocessor, but some are for microcontroller purposes, like embedded microprocessor. Their series is like 8080, 8051. This is one of the example, 8051. It is mostly used in most of the Arduino and many types of microcontroller. 80186, 80188, and then so on. So like that. So you understand what is called reprogrammable and what is called embedded application. Is it okay? Do you understand? Clear? So yeah, so this is okay. So I'm saying microcontroller or embedded control. Embedded control applications in which the microcomputer performs a dedicated control function, you know, a dedicated function, and it is primarily embedded control application, that is primarily event control, is a microcomputer used for industrial process control. Sometimes we use it for project, you know, Devices developed specifically for embedded application are of low cost and high integration. These are the normally you know the Arduino is very cheaper now. 300 real, 200 real, something like that. So it's very cheaper, but we can use it for certain type of applications, to perform some project operation, something like that. For instance, 8051 offers a one order of magnitude higher performance. It has a very good performance, and especially on chip functions such as ROM, RAM, and many things are in one board. Main things. So example is microcontroller. In microcontroller is one board. One board has all the things: microprocessor, input output interfacing, and memory interfacing, memory, everything is there. RAM, ROM, everything is inside there. So the processor, they have the different types of processor. This is called embedded processor. Okay, so this is about the things. And reprogrammable is reprogrammable processors are used in the microcontroller. I mean, microcomputer systems like laptop, desktop, something so on. Okay, so now we can see something more like first generation microprocessor are like 8086, 8088, and then second generation is 80286, third generation is 80386, and something like 80386, SX, SLC, so on. Fourth generation, fifth generation, So in fifth generation, you can see, in addition to Pentium, there are something else like AMD. AMD is another company. They also produce processor, and Cyrex also. They are Celeron. Celeron. Yeah, you can see the Celeron. Celeron is also there in the second generation. Sorry. In a second generation, sixth generation microprocessor, Celeron. Now also Celeron always so Celeron processor, it is little bit cheaper. Okay, in a motherboard you can see, if you open the laptop or desktop, you can see there is a board. It's called motherboard, and board has many things. One of the thing is, this is called the processor. You can see this one is the CPU, number one CPU, and the number two, it's the memory slot, RAM memory slot. Where is number two? This one, you can see this is called number two. It's called RAM slot. And number three, these are the extension slot. Extension means, like you can extend, if you want to add some external things, you can do it. Sometimes, if you want to increase the memory, for example, you have like one memory, you use one memory slot. There are another one is extra is there. That means if you want to extend the memory size, you can do it. And here number three is extension slot, and number four is okay. So storage connector, number four, you can see this one is storage connector. And number five is keyboard and mouse, PS2 connector. Number five, you can see we can use the keyboard and mouse, PS2 mouse, because mouse is also, they have also different types. And graphics connector, which are actually used to connect the monitor, or graphics. Are number six, you can see here is the graphics connector. Then USB port, number seven, you can see there is some USB port. And number eight is network or LAN card, for HDD. Number four, right? Yes, number four. This is for it. And network port. So like sometimes if you want to connect it to the via internet connection, we need internet connection. So number 8 is there. Number 9 is audio port. So these are the basic. It's not details. Some like basic information. And Gigabyte is the company. Motherboard company is Gigabyte. So Gigabyte is a company name. So these are the things. And if you look at the hard drive, it is a simple picture is like that. you know, it has a disk, you know, disk. So each one, it has a, I mean, only many memory cells are there. So memory cells, how can we, so based on the address information, it will go, it can access the certain memory. And so it is a disk type. And actually this one, this needle, this one is actually moving part. So it actually moves on yeah, to access a certain cell, something like that. And circuit board front. So it's just like a, I mean, just have a look. Okay, so it's not about like you have to, I mean, just for information. Okay, so that's about this chapter is basically about the basic information. So you don't have to memorize anything. If there is any question, you need to if you just for reading mostly, yeah, if you need anything, I will let you know. Okay, so this is all for today. Do you have any question? Okay, all right. Okay, thank you. Wish you all the best.